Good afternoon. Ask your friends to join. Anish Jain, is it your first class? Anish Jain,
Yes, sir. Yes, sir. First
where
class.
were you these many days?
Sir, I was taking my college documents, sir.
Huh?
I was busy, sir, taking my college documents,
No,
old
no,
college.
no. I have completed two modules, so not even attend a single class. This is your first class. Where were you these many
Sir,
days?
he is new admission, sir.
I'm
New
new, sir.
admission.
Yeah,
Okay,
new
okay.
admission,
You're
sir.
a diploma, right?
Yes, sir.
Okay, okay.
Okay.
Okay, I'll be starting. In the previous round, there was network issue and we have stopped at this point. Okay, now I have to take in this problem. Now I have to take the bending moment. Bending moment in the sense, if I take this, if I take this length from here to here, this length is x. X minus 3 will be this. X minus 3 will be this length indicated in red. X minus 3 will be this length. Therefore, centroid from here to here, this is x minus 3, this is x minus 3, x minus 3. This will be 2h by 3, 2 into x minus 3 by 3. This length is 2 into x minus 3 by 3. That's what I have taken. So I have taken 50 into x, 50 into x. This is causing smiley face 50 into x. This is minus 33.34 minus 100 minus 30 into x minus 2. The entire load what I have taken, this is of magnitude 20, sorry, 30, this is 30 into x minus 2 is this load. Which load? This load, point load, 30 into x minus 2. And then this is 20, 20 into x minus 3, 20 into x minus 3 will give this length. 20 into x minus 3 will give this much. This is the length. 20 into x minus, I am subtracting 2 and 1 from x, remaining length will be x minus 3. 20 into x minus 3 will be magnitude of this load. This is the magnitude of into b into h of into 20 into x minus 3. And then the perpendicular distance is from this point to this point is 2h by 3. 2 into x minus 3 by 3 is the perpendicular distance. 2x minus 3 by 3. If I substitute m at x is equal to 3, I will be getting minus 33.34. M at x is equal to 5, I will be getting 0. That's what I have plotted. That's what I have plotted. X is equal to 3, there is 13.34, and x is equal to 5, this is 0. Since this is linear, this has to be quadratic. This is linear in the sense this has to be quadratic. Why I have to be? This has to be quadratic. This has to be quadratic. Let me see that. Now this is quadratic. X square terms will come here. This is not cubic. This is quadratic. We'll go ahead with the next problem. As we announce, go ahead and solve many problems, we'll come to know how the difficulty or ease the problems. We'll find it relatively difficult, another 3 or 4 problems. Once if I solve many problems, we'll come to know. Take this problem. This is a beam subjected to UDL. This is the overhanging beam A, B, 10 meter, C, D, 2 meter, 2 meter. Okay, this is RA, this is RB. Okay, let me write. here. First, summation of summation of vertical forces is equal to 0, or this is of magnitude 50 kilonewton per meter. 50 kilonewton per meter. Summation of vertical forces are 0. Force acting upwards is positive. Therefore, RA plus RB minus 50 into 14 is equal to 0. Can you tell me what is RA plus RB? RA plus RB, which is equal to 14 paisa. How much? 5 for the 20. 14 paisa. It was 14 paisa 70, right? 70, 700, 14. This is, sorry, this is 5, not 50. This is 5. 14 paisa 70. Okay. Summation of moment about T is equal to 0. Clockwise moment is positive. Therefore, for a simply supported beam, it won't resist the moment. It won't resist the moment. Okay, there cannot be any moment at the reaction. So only the vertical and horizontal force comes into picture. Therefore, let me write. I'm taking moment about A. Shall I write? What I can do? I'll write like this. Uh, Positive. This is of negative side of A, and this is this force into this. This is causing anti-clockwise moment. About this point is anti-clockwise moment. Part CA minus 5 into 2 is the bending moment. Minus 5 into 2 into x by 2. X by 2 is 1. Okay. Minus 5 into 2 by 2 by 2 is 1. Okay. And this is causing clockwise moment. And this is causing clockwise moment. This 5 kilometer on 10 meter length. This is plus 5 into 10, 5 force into perpendicular distance into 5, x by 2 is 5. Okay. And then and then what I can write, this RB about A, this is causing anti-clockwise moment, minus 10 RB, minus 10 RB, and then this is causing clockwise moment, plus 5 into 2 into, now you see, 2 into x by 2 is 1 plus the remaining distance 10. Therefore, RB, I'll be getting it as, can you tell me, minus 5 to the 10 plus 5 5 is 250 minus 10 RB plus 10, 11, 10, 11, 110. Okay, 250 minus 10, 250 plus 110 is 360, 360 minus 10, 350 minus 10 RB minus 10 RB plus 350. RB is equal to 35 kilonewton. Okay, RB is equal to 35 kilonewton. Okay, so let me replicate this figure once again. Before that, RB is equal to 35 kilonewton. RA plus RB is equal to 70 kilonewton. Therefore, RA plus 35 is equal to 70. Therefore, RA is equal to 35. RA is equal to 35 kilonewton. This will be 35. This will be 35. The first step is to find the reaction forces. Next, we need to plot the shear force and bending moment diagram. A, B, 10 meter, 2 meter, 2 meter, 5 kilonewton per meter, right? Figure segment figure shear force and bending moment. Give me a moment. RA and RB are 35 kilonewton each. 35, 35, 35. Okay. Next, shear force acting upwards. This is positive. Downwards from the x-axis section on the left hand side is negative. This is in the same dimension. Okay. Bending moment obviously. Section x-axis. This is positive. Section x-axis negative. This is my bending moment at shear force convention. Now segment, segment. This is CND, right? CD, segment CD, x greater than or equal to 0, less than or equal to 2. I have to write sketch like this. Here I am passing a section somewhere here. X1, 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 X1. This is distance x, and this is of magnitude 5 kilonewton per meter. Okay, I have not taken R into consideration. You should look at. So I can write this as effective load, total effective load. This is x, 5 into x acting at this point. This is x. Okay. Now force SFD force is equal to summation of vertical forces, or which is nothing but F shear force F is equal to 5, since this is acting downwards, minus 5 into x. F at x is equal to 0, which is equal to 0. F at x is equal to 2 is equal to minus 10. Okay. Let me plan this. Load diagram, shear force diagram, bending moment diagram, C, A, B, D, C, A, B, D. F at x is equal to, say, shear force. Let me do the bending moment also calculation also. Bending moment M is equal to summation of moment about xx. M is equal to moment about xx is this is bending the beam in this fashion, which is negative. Therefore, hogging minus 5 into x is the magnitude, and the distance, this is the centroid, and the distance, the center is x into x. x by 2. M at x is equal to 0 is equal to 0. M at x is equal to 2, which is equal to minus 10 kilonewton meter. Okay, kilonewton. Okay. This is constant load. Load is constant. Therefore, shear force is linear. Bending moment is parabolic or quadratic. You should look how I plot the curve. I can't go to the previous slide always. You have a look at this. Shear force at x is equal to 0 is equal to 0. At x is equal to 2 is equal to minus 10. Minus 10, I'll be plotting this. This is a linear. This is constant. This should be linear. 10. Bending moment at x is equal to 0 is equal to 0. This is 0. At x is equal to 2, it is equal to minus 10. Minus 10. Sorry, this is how much? Minus 10 alpha. This has to be downwards. Shear force, what we got? Minus 10, this should be downwards. Bending moment also minus 10, this should be downwards. Minus 10, this is linear. This is cubic. How I plot the curve, you should know. And the shear force, this should come here like this. This is up to here like this. Now see, I will just plot myself, but in the you should observe how going back to the previous slides. Okay, previous thing which I've discussed in the previous class. The shear force diagram is like this. This is minus 10. This is the point. Assume this is the point. This is like this. Which curve will, which shear force diagram will suit? You have to look into it. Okay, the curve was like this. Shear force was like this. The two negative, it will suit like this. Therefore, the slope will be like this. Therefore, the slope will be like this. The bending moment curve will be. I cannot read this. It will be something like this. Okay. Next. Segment AB, x greater than or equal to 2, less than or equal to 12. Figure, let me read the figure. Class. 5. This is RA 35. This is 2. I have passed the section here. X2. This is the distance x. Okay. Now you should remember that when I'm talking about the UDL, I'll consider all the force from the left hand side. Okay. This point is A. This is C, D, A, C. Okay. And then this is I'm not going up to B point. I'm somewhere passing the section here. X2. Okay. Now see, this distance is x. This distance is x. Therefore, the magnitude and the load will be 35 as it is. Magnitude of UDL, this is x. This will be at centroid 5x. This is at the centroid 5x. This is at a distance x by 2. The remaining distance is x by 2. In the previous class, we discussed problem like this. This is point A. There's a UDL, and this is point B. There is a UDL like this. Okay, and I'm passing the section like this x. This is say 10. So this is 2. This is A, B, C. If I want to take the moment about x, m is equal to, okay, then what I did, if this distance is entirely x, this distance is entirely x, I subtracted this x minus 2. Then what I write, RA into this 10 into this distance, 10 into x, and then this minus of whatever it is, minus of this UDL say 5 into x minus 2, into x minus 2 by 2. That's how I wrote x minus 2. This is the center, x minus 2 by 2. That's how I wrote. But in this case, what happens is the entire radial I have to consider towards the length. Therefore, the entire x comes into picture. X comes into picture. Therefore, this is 5 into x into remaining half of the distance is x by 2. Hope you understood this. Okay. Force is equal to SFD is equal to summation of vertical forces f of phi, which is equal to, okay, acting upwards is positive, therefore 35, 35, and then there, since it's a UDL, I have to take in terms of x, okay, linearly varying 35, acting downwards is negative according to our convention, minus 5 into x. F what x is equal to 2, which is equal to 35 minus 10, which is equal to 25. F what x is equal to 12, which is equal to 35. 35 minus 12 is a 60, which will be equal to 25. Right? 25. 25 correct again? Yeah. F what x is equal to 2, 35 minus 2, this is 25. F what x is equal to 12, 12 is a 60, 60 minus 35, 40 is 25. Give me a moment. Okay, this is minus 20. Minus 20. Moment is equal to summation of moment about xx, which is equal to, carefully you see it, this moment, this is 2, this is x, therefore this due to this point 2, this will be 35 into x minus 2, this is bending the beam like this, which is this has to be minus 35 into x minus 2, this is negative, and UDL, how it is sorry, this is bending in the upward direction like this, like this is positive, this UDL is bending in the downward direction like this has to be negative, minus 5 into x is the magnitude into half of the distance is x by 2. Therefore, it will be equal to m at x is equal to 2, which is equal to 5 minus 10, m at x is equal to 12, which is equal to 35 into 10 minus 5 into 12 alwa, 5 into uh, 12 square by 2. Can you tell me which is equal to 350 minus 12 square, 5, what can I write? 5 into 144 by 2. What would be this value? 350 minus uh, 5 into 7, 2. Tell me this value. 5 to the 10, 72 into 5, 5 to the 10, 5 7 35, 360 minus 10, which is equal to minus 10. Okay, minus 10, this is my kilonewton, this is kilonewton meter, force into distance is kilonewton meter. Okay, yeah, this is, since it is UDL, this is load is constant, shear force will be linear, bending moment will be cubic or sorry parabolic or quadratic, quadratic. Okay, okay, this is constant, this is linear, this is quadratic. Okay, so we need to plot this. F at x is equal to 2 is 25, at x is equal to 12 is minus 25. F at x is equal to 2. ನಮ್ಗೇನು ತಪ್ಪು ಬಂತಾ? Oh, there's a point load, sorry. There's a point load. Since there's a point load, if you don't have the point load, then at x is equal to 2. If you come from left hand side or right hand side, you should get the 10, same 10. X is equal to 2, this 25 like this, and at x is equal to 12, this minus 25 like this, minus 25. The curve, okay, and this is the point where shear force is zero. Shear force in the sense dm by dx is equal to f, dm by dx is equal to 0 means slope is, bending moment slope is 0, in the sense you will get a bending moment like this whose slope is 0. It means that my bending moment is maximum at this point. We will find that maximum point later, but this is the point where bending moment is maximum. Okay, so zero slope, shear force or zero slope, the point where the slope is 0 or the shear force is 0 is the point where the bending moment is maximum. Okay, now we go, we have to bending moment at x is equal to 2 is minus 10, at x is equal to uh, at x equal to 12 is also minus 10. Okay, this is minus 10 minus 10 banta. Check it out. Okay, minus 10 minus 10. But see, I cannot plot minus 10 by minus 10. I cannot plot minus 10 and minus 10. I don't know. This is also minus 10. This is also minus 10. Whether curve is like this or whether curve is like this, I don't know. Whether it is like this or like this, I don't know. So what I will do, I'll locate this point and I'll find the maximum bending moment. Okay, I'll locate the point. How I will locate this point? The shear force is zero at this point. I'll consider this point. You consider this point. The equation is 35. F is equal to 35 minus 5x. Or if shear force is 0, bending moment is maximum. 35 minus 5x is equal to 0. Or 35 is equal to 5x. Or x is equal to 7 meters. From 7 meters from the left hand support, bending moment is maximum. Okay. To find maximum bending moment at x is equal to 7 meters. Therefore, I will take that equation 35x minus 2 minus 5x square by 2, m is equal to 35x minus 2 minus 5x square by 2. That's 535. 35x minus 2 minus 5x square by 2. At x is equal to 7, bending m max at x is equal to 7, 35 into 5 minus 5 into 49 by 2. Can you tell me this value? Say, tell me soon. Tell me this value. Yes. Ekala ಹೇಳಿ ಬೇಗ. How much? 35 into 5 minus 5 into 49 by 2.
126.
Correct ನೋಡಿ. 35 into 5 minus 5 into 49 by 2. How much?
52.5.
52. Raghavendra, Yakri, why you make these mistakes?
Sir, I thought that 5 has 2. I did 2 into 49 by 2.
Please concentrate. 52.5 kilonewton meter. So bending moment, I'm getting a point where the bending moment is maximum. This point is 52.5 kilonewton meter. Therefore, I got one more point. The variation curve we should look at. The shear force is like this. I'll take back to that slide. Shear force is like this. Positive shear force. Shear force is ಹಿಂಗೆ ಅಲ್ವಾ shear force ಇರೋದು. How is the shear force? Shear force left hand side upwards is like this. This positive shear force. This is the shear force. Therefore, the curve will be this curve. This is the curve, last curve. Last curve, bending moment curve will be like this. Okay, let me write that. You should always look that. Always look for that. You should not merely do like that. Okay. Therefore, this curve will be like this, and also this curve you look there will be like this. Okay, if in the examination you will give find the maximum bending stress. Maximum bending stress is the point where the shear force is 0 or slope. See, the slope of the bending moment is 0. If you draw a tangent, y is 0, x is there, y is 0, 0 by something is 0, slope is 0. Okay, and then if you ask the maximum bending moment where the shear force is 0, equate that to 0 shear force equation and get the distance, and you can substitute that x value into a shear bending moment equation and get the maximum bending moment. Okay, now and also if in case a point of these two are the point of contracture where the bending moment changes the sign or where the bending moment is 0, this distance we need to find from point C to this, that we can find later. Okay, point of contracture. This is in which region? If you say this is in region A to B. In this, if I take this equation, bending moment equation, 35 x minus 2 minus 5 x square by 2. If I substitute this to 0, whatever the value I will get, this is the point of contracture. Okay. Now, I have completed CA region and AB region. Let me go to the BD region. Last 10 minutes is remaining. Also from 2 to 3:30 I will be taking the class. Rakesh sir is unable to take the class. He is on some other work. I will be taking this class. Okay, 2 to I will complete another 2 to 3 problems, another 2 or 3 varieties of problems. The problems which I completed and solving now are on simply separated, which you should notice. Segment CD x greater than or equal to 12, less than or equal to 14. Let me draw the figure. I pass the section here. X3, X3, X6, X6, 35, 35, 2, 10, 5. Now, if I write like this, X6, X6, C, C, A, 35, 35. This distance is x, this distance is x, and this is 5, this is 5. Therefore magnitude of this will be 5x, and half of the distance will be x. This is x by 2. The remaining distance is also x by 2. Force into perpendicular distance, 5x into x by 2. Okay. Force is equal to summation of vertical force, SFD, summation of vertical forces, which is equal to acting upwards is positive 35 plus 35 minus 5 into x. F at x is equal to 12, which is equal to 70 minus 60, which is 10, right? 70 minus 60 is equal to 10. F at x is equal to 14, which is equal to 70 minus 14 5 is 70, 15 5 is 75. Okay, 70, which is equal to 0. Always, when you get to the last point, you should get shear force is equal to 0, and bending moment also should turn up to 0. Then it is only the right moment. Bending moment is equal to summation of moment about x. I'm taking summation with all the moment from the left hand side, all the shear force, all the vertical forces from the left hand side. Okay, moment, which is equal to, yeah, this force 35, this is 2, this is 10. Let me write the vertical forces first. It is the point force 35. This is, if I call this as x, this is x. 35 x minus 2. This is how it is bending. It is bending the beam like this. This is positive, plus 35 x minus 12, x minus 12. Now I am coming to the UDL. UDL is bending the beam like this, minus 5 into x. This is the magnitude of the load, 5 into x into x by 2. X by 2, right? 5 into x into x by 2. Okay. 5 into x into x by 2. That's right. Okay. M at x is equal to 12, which is equal to 35 into 10 minus 5 into 12 12 are 144, 144 by 2. M at x is equal to 12, which is equal to 350 minus 75 into 72, or 3 5 to the 10, 5 to the 15, which is equal to minus 10. Okay, I'll be writing it here. M at x is equal to, we should come back to 0, 14, which is equal to 35 into 12 plus 35 into 2, 35 into 2, 14 minus 12 is 2, minus 5 into 14 into 14, 14 square by 2, 35 into 12. You tell me how much it is, you should get is 0. You calculate meanwhile, tell me, one of you tell me how much you are getting. 12 5 is 60, 12 is 24, 300, 12 is 60, 12 to 24 is 36, 36, 12 to 24, it's 36 is 40, 400 plus 70, this is 14 square is 256,
0, sir.
0, right? Minus that is equal to 0. Therefore, let me plot it. F is, this is constant load, therefore shear force part will be linear. This will be quadratic or parabolic. This is second order. That's it. Okay. F at x is equal to 12 is equal to 10, and at x is equal to 14 is 0. This is F at x is equal to this one 12 is 10. See, there is sudden rise like this. And when there is a point load, there will be sudden rise like this, which is equal to 10. Okay, except 14, this will drop to 0. This is symmetric. Sorry, this is positive 10. Okay, okay, positive 10. Therefore, this will go. It has to pass to point B, positive 10, like this, positive 10, and then back to 0. Symmetric. Okay, bending moment m at x is equal to 12, which is equal to minus 10 and 0. X is equal to 14 is equal to 0. X is equal to minus 12 is minus 10. This is the point I got, this is the minus 10, and x is equal to 14. The curve slopes like this. Sorry. Curve slopes like this, which you can see if you see this triangle. If I go back, if I go back, see, it is a curve like this, right? It is a shear force is like this. Shear force was something like this. Therefore, this is the shear force. The curve should be like this. That's what I've written. That's what I've written. The curve going like this. Okay. This completes the problem. In this problem, the feature which we added was the point where the bending moment was. We have found the maximum bending moment and its location. It is at 7 meters from the left hand support, from the left extreme end, not from the left hand support, from the left extreme end. Okay. In the next class, we'll talk about point of contracture and we'll solve another 2 to 3 problems. Okay. I will stop at this point, and 2 to 3:30 I will be engaged in a class. Okay. Any doubts you can ask me. Okay, I'll stop at this point.